Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to see the questions from Module 1, which is Electrochemistry and Corrosion, which is nothing but the battery chemistry and corrosion. We are going to see the questions on this topic. Here, first, these questions are problem solving and critical thinking questions. And here, the first question is why lithium is the best reducing agent, whereas fluorine is a best oxidizing agent. Explain. We are going to explain. We are going to see why this lithium is the best reducing agent, whereas fluorine is a best oxidizing agent. If we see in the electrochemical series, here lithium is the strong best reducing agent, whereas the fluorine is the oxidizing agent. So according to the electrochemical series and the electropotential, here the EMF values, we are going to categorize this according to the electrochemical series. Here from lithium to fluorine it increases. So the oxidizing agent, their oxidizing nature increases. So here it will act as this lithium is the last place, so it acts as a best reducing agent, whereas in this the standard potential V is decreased from fluoride to lithium. So this here the fluorine it will act as a strong oxidizing agent. So here according to the electrochemical series, the lithium ion has the best reduction potential in the series, which means it acts as a best reducing agent. So F as the fluorine has the highest reduction potential, thus fluorine oxidizes easily with another substance very readily and easily. So it acts as a best oxidizing agent. So moving to the another question, which is what is the composition of the salt bridge? So used in between the two half cells. So why is salt bridge used in construction of a half cell? So the salt bridge is a vital component of any voltaic cell. So this is the salt bridge. So there will be two electrodes, one is anode and one is cathode. So it was dipped in its respective solution. So here the salt bridge is connected in between the two electrode and anode containers. So it is a tube filled with an electrolyte solution, commonly NaCl, such as KNO3 or KCl, and NaCl are generally used in this salt bridge. The purpose of this salt is to keep the solutions electrically neutral. Here to keep the solutions electrically neutral, this salt bridge is used. It allows the free flow of ions from one cell to another. So this is the one cell and this is the another cell. So it keeps the ions to move easily flow from one to the another. So without the salt bridge, the positive and negative charges will build up around the electrodes, causing the reaction to stop. So in order to avoid the stopping of the reaction, this salt bridge is used in between the two cells, which is one is anode and one is cathode, and this is the salt bridge. Here we can see here K plus, and here the KNO3 was used, potassium nitrate was used, here the K plus ions and nitrate ions. So it makes the flow of electrons from one to another. So this is the usage of the salt bridge. So coming to the another question, what are electrolytes and what are the electrodes used in lead acid battery and lithium ion battery? Here a lead acid battery consists of a positive electrode. So here the positive electrode is the lead oxide. Here positive electrode is lead oxide PbO, and it is made, a negative electrode is made up of pure lead Pb, and an electrolyte here is H2SO4 sulfuric acid. Here this is about the lead acid battery. The name itself indicates lead and acid. Here the positive is lead oxide and negative electrode is pure lead, and the electrolyte is H2SO4. Here we can see Here this is the electrolyte, and lead, this is the positive, negative. Positive is here and negative is here. So this is the construction of a lead acid battery, and this is the lithium ion battery, LIBs. LIB. Here we are seeing what are the electrodes. Here these are the electrodes used, positive terminal or negative terminal. Positive is nothing but the cathode and the negative is anode. And the electrolyte solution, which is nothing but the sulfuric acid in lead acid battery. Coming to the lithium ion battery, here the positive electrode, here the positive cathode is lithium oxide and lithium LiCOO2, lithium cobalt oxide, lithium cobalt dioxide, and here the electrolyte is the lithium salt in an organic solvent, which is nothing but the lithium. Electrolyte here is lithium hexafluorophosphate or lithium tetrafluoroborate. So these are the electrolytes commonly used in lithium ion battery, and the anode negative terminal is a carbon rod or a graphite with intercalated lithium ions. Generally intercalated, these dots are the intercalated lithium ions, which is used as a anode with graphite, and cathode, which is the lithium oxide or lithium cobalt oxide, and electrolyte is lithium salt, which is in organic solvent, nothing but lithium hexafluorophosphate. So this is generally used in lithium ion batteries. So coming to the another question. So the copper gets deposited on iron nail immersed in copper sulfate solution. What are the reasons? So if we see, when an iron nail is dipped in copper sulfate solution, here the iron nail is, this is blue colored solution, is the copper sulfate solution. When it was dipped in the copper sulfate solution, so the iron can displace copper ions from its solution. So the iron nail gets coated with a brown layer of copper, and the color of the blue color copper solution changes to pale green. Here we can see the iron present in the iron nail when inserted into the copper sulfate solution, it forms a layer on it, which is a brown layer of copper. So, and once it formed the layer, the color of the solution is converted into the pale yellow. The reaction here going to happen is iron plus copper sulfate going to gives rise to copper plus iron sulfate. So this reaction, this iron got deposited on the, this copper got deposited on the iron because of the standard electrode potential. So can we store copper sulfate in zinc vessel or silver vessel? Justify. So if we see, the copper is less reactive than zinc. Comparatively, copper is less reactive than zinc. Zinc will replace the copper from its salt solution. When the copper sulfate CuSO4 is stored in zinc pot, the copper is replaced easily by zinc in the copper sulfate solution. So the copper solution cannot be stored in a zinc pot. So why does a steel pipe in a, here if we see, the zinc rod is dipped in a copper sulfate solution. We can see it because of its displacement, the zinc rod is eaten away in the copper sulfate solution. So coming to the another question, why does a steel pipe in a large copper tank corrode and causing rapid destruction? So we have to justify. So here iron or steel is anodic, so which is a negative terminal with respect to compared to Cu copper. When a steel pipe fitted in a large copper tank is exposed to atmosphere, the galvanic corrosion occurs. It starts, and the anodic metal iron or steel starts the corrosion process, because it is when it was exposed to atmosphere, it starts corrosion process. So the another question on the calculation of EMF of voltaic cell, which is iron 2 plus aqueous solution and copper 2 plus aqueous and copper electrode, give the electrode potential of copper and iron, which are the given minus 0.44 volts and 0.34 volts. Here the copper is minus, here the copper Cu2 plus, here the electrode potential of copper and the iron are given in the question. Here iron is going to convert iron 2 plus and 2 electrons. It is going to oxidize. So the copper is going to reduce. So the copper plus 2 electron gives rise to copper. Here the EMF of the iron is minus 0.44 volts. Here the copper plus 2 electrons which is reduced will give the EMF of 0.34 volts. Here by how to calculate means E cell is equal to E cathode minus E anode. Cathode means nothing but 0. Copper which is going to reduce, it is called the cathode, which is going to give electrons is called the anode. So here definitely the anode here, this is the cathode. So it loses 2 electrons. The ionization oxidation process is going to carry on at the anode. Here the minus 0.34 volts minus 0.44 volts will give 0.34 plus 0.44 volts. So the final the EMF of the cell is 0.78 volts. This is called E cell. So the another question is, the galvanized container is not used for storage of food products because but tin coated container is used. So the comment on this statement. So coming to here, the galvanized containers cannot be used for storing acidic foodstuffs such as zinc reacts with the food acids, forming some poisonous substances or compounds. The tin coated containers and utensils can be used for storing any food stuff. And as tin is non-toxic and protects metal from the corrosion. So here the galvanized containers is not recommended because it reacts, the zinc present in it reacts with the food acids present in the food. It causes the poisonous compound release. So it is not advisable and it is not for storing. Galvanized containers are not used for storage. Where tin is used for storing any food stock, it is non-toxic and it also prevents it from corrosion. Here the iron does not rust if the zinc coating is broken in a galvanized iron pipe, but rusting occurs much faster if the tin coating over iron is broken. Here we have to justify. So the zinc is more reactive than iron. If we see here, the zinc is more reactive than iron. So this means that if a crack appears on the surface of iron coated with zinc, then zinc will take part in the redox reaction and not the iron, because here it is, we can see the EMF. So based on the electrochemical series, these reactions will happen. So in another words, zinc will be corroded in surface to iron, but same is not in the case with the tin. It is less tin. We can see tin here. So it is very less reactive than iron. So it is zinc. So here iron, here tin. So it is less reactive than iron. So here it is, this case won't happen and won't repeat with the tin. So what is galvanic cell? Explain the construction of galvanic cell with electrode reactions. So this is the galvanic cell here. The zinc is dipped in its respective solution zinc sulfate, and the copper is dipped in copper sulfate solution. Here the overall reaction is zinc solid and zinc sulfate aqueous and copper sulfate and copper solid, here copper solid. Here this is the salt bridge. The salt bridge is KCl, so which dissociates into K plus and Cl minus ions. So the oxidation is going to happen at zinc. So zinc is going to lose its electrons. The electrons thus released to move towards the cathode. There it got, the copper will gain these 2 electrons and got reduced. So the reaction is at anode, zinc is going to give Zn2 plus 2 electrons, which is nothing but oxidation. And at cathode, this is negative terminal. And here, this is negative terminal oxidation. Negative terminal. At cathode, the copper gains 2 electrons and it got reduced to copper, which is called reduction, which is the positive terminal. These both are connected by the electrolyte solution or the salt bridge, which is KCl. So the salt bridge is filled with the KCl, the electrolyte solution. So This salt bridge causes the movement of ions from one to another, positive to negative or negative to positive. This causes the passage of ions in between the two cells. So the overall reaction is zinc plus copper. See here, zinc plus copper gives rise to zinc 2 plus copper. Here zinc is converted into zinc 2 plus and copper is reduced to copper ion. So explain the construction and working of lead acid battery. Write the discharge and charging reaction and limitations of lead acid battery. Here two processes are going to happen in the lead acid battery, which is here the electrolyte is here anode is lead. Here the negative terminal is lead and positive is lead oxide, and the electrolyte is sulfuric acid H2SO4. So at anode, what happens? The lead loses its electrons and the oxidation is going to happen. It is converted into Pb2 plus 2 electrons. So the Pb2 plus the electrolyte releases H plus and SO4 2 minus ions, thus reduced. That oxidized lead is going to react with the sulfate ions, will result in the formation of lead sulfate. So the overall reaction at the anode is lead plus SO4 2 minus ions gives lead sulfate plus 2 electrons. So whereas here the lead oxide, this is at cathode, this is at a cathode. So the lead oxide, the positive terminal lead oxide reacts with the 4 plus ions and the 2 electrons gained from the anode. So once the electrons are released at the anode, they travel and they reach the cathode. So here we can see the 2 electrons. So they reach the 2 electrons to the cathode. So then lead oxide is going to react with the 4 H plus ions and 2 electrons and gives rise to lead 2 plus and 2 H2. So thus formed lead plus again SO4 2 minus ions present in the electrolyte reacts and results in the formation of lead sulfate. So the overall reaction at the cathode is lead oxide plus 4 H plus ions plus 2 electrons plus sulfate ions gives lead sulfate plus water. So the overall reaction for this is, so here the Pb2 ions will consume the electrons, so it reduces to lead. So the Pbs plus 2 electrons are converted into lead. Here the PbSO4 plus 2 H2O gives rise to PbO2 plus 3H plus minus 3H plus ions plus HSO4 minus plus 2 electrons. So the overall reaction from anode and cathode is lead sulfate plus 2H2O plus energy. It gives the lead plus lead oxide and 2H2SO4. So this is going to happen in the lead acid battery. So the coming to the limitations, it is very heavy. Batteries tend to be very large bricks because the energy density is very low. So these lead oxide plates are were set up in like a racks, which was dipped inside a acid solution. So they are very heavy. This is one of the disadvantage. So explain the rusting of iron with the help of electrochemical theory of corrosion. Here the iron rusting is due to the reaction with the oxygen or atmospheric humidity or moisture. Here what happens? The iron is going to oxidize. It is going to release its electrons. So it attains its a form which is Fe2 plus 2 electrons. So at cathode, the hydrogen ions are formed due to the acidic environment and the following reaction occurs in the absence of oxygen. So here the 2 H plus ions plus 2 electrons will give rise to H2. So the overall reaction is the iron at the anode and 2 H plus ions from the cathode gives rise to iron 2 plus and H2. Here we can see this is a surface of a pipe or steel. So here the anode, the iron is going to convert into iron 2 plus. So these ions plus 2 electrons. So the ionic current, again it going to react with of O2 plus H2O. The 2 electrons from here gives rise to 2 OH minus ions. It is going to happen at the cathode. The overall reaction is Fe2 Fe plus 2H plus gives rise to Fe2 plus and H2. Here, the Fe plus 4H plus O2, it also gives Fe2 plus ions plus water molecules. So the ferrous ion Fe2 plus ions is further oxidized by the oxygen. It is going to react with the more oxygen, which forms rust. So thus formed Fe2 plus ions are going to further react with the oxygen. So here the 4 Fe2 plus O2 plus water molecules from the moisture, humidity, oxygen going to convert into iron oxide. Here plus 8 plus 8H plus ions. This is nothing but the corrosive product. This causes the corrosion on the surface. So what is cathodic protection? Explain the sacrificial anodic protection and method of controlling corrosion and its applications. Here, what is cathodic protection means the method of protecting metals and alloys from corrosion making them completely cathode. Generally, this corrosion starts from the anode. So, first the corrosion starts at the anode because it is going to oxidize it, then it releases electrons. So, here the corrosion starts at anode, we are making it completely cathode. Thereby we can eradicate the corrosion. We can prevent the corrosion. So the metal to be protected from the connection is connected to more anodic material, like this is the sacrificial anodic protection. Here this is unprotected metal being corroded. Here we are going to use the sacrificial anodes, which are nothing but magnesium, aluminum and zinc and their alloys. So here the protected base metal is coated with this magnesium, zinc or aluminum alloys. Therefore, it corrodes, making it as a barrier between the base or protected metal and the corrosive environment. Here the example is a ship hull, which is made a ship hull. Here we can see this is a ship. So the hull is always in contact with the water. In the oceans or the seas, it is always in contact with the water, making the environment more corrosive. So here we are making a barrier by using these sacrificial anodic materials, which are nothing but the zinc, aluminum or magnesium, or their alloys is used or coated on the surface of a protecting metal. So which undergoes corrosion, leaving the base metal protected. So these zinc blocks are used, is connected to the sacrificial anode zinc blocks, and which undergoes corrosion, making the base metal protective. So the another one is define electroplating. Explain the process of electroplating of copper. Here another question is define electroplating and explain the electroplating of copper. So the electroplating is a technique or a process of coating a metal with a thin layer of another metal by the process called electrolysis to improve the metal's corrosion resistance. So the electroplating is also known as electrodeposition and electroplated coating. Here in this process, a thin layer of metal is coated on the surface in order to make the metal corrosion resistance. Here we can see the copper plate is used to coat on the iron object. So this is a copper sulfate solution. So these are the questions from the battery chemistry and corrosion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.